this dvds. S is this one going all the way up. What is this? This is for a linear displacement graph. The gradient or tangent, the gradient of tangent means that dy dx at any point is the same. Thus, the instantaneous velocity of this particle at any time is uniform. See, this one is uniform. Why uniform? Because gradient, the same gradient. How do you know that it's same gradient? Hey, come on. This is same gradient. Gradient is the same. Okay, the velocity, this velocity that is uniform is called constant velocity. If I were to ask you to draw a graph of constant velocity, okay, let me test you again. This is in second and, this is V. I want it to be V. V in meter per second. Okay, I want you to draw me the graph of velocity. How will the line be? Okay, let me have it as blue color. I give you the blue color. I give you the blue color. Okay, the blue color. I give you the green color. I give you the purple color. This is purple. Purple color, gray color, purple color. Very light. Okay, purple color. Okay, then I give you the gold color. So I got 4. Which one will be your velocity? Blue, green, purple, gold. Which color to represent this? Can you tell me which one is your answer? The blue color. The blue color. Everyone say blue. Okay, can you justify? Very good. Oh, congratulations. You get it right. I'm very happy. I do not know whether my lesson is achieve the objective or you yourself memang pandai. Ya, short sendiri. Okay, can you please explain, justify your answer? Why? Why you say it's blue? Okay, I need to click the answer first. You say it's blue. Okay, why you say it is blue? Why you say it is blue? Justify your answer. Type your answer. I want to read your answer while I take this one first. I short sendiri because I'm very happy. Some of you, I didn't say all, because I do not know how many of you paying attention to this topic. Okay, let me go back here. Constant gradient, so gradient, constant velocity, because it's constant velocity. It can be green. Why not green? Why it is not green? When you say constant velocity, green color also constant. Let me give you a value. Okay, let's say this is 3 and this is -3. Green color also a constant. My question asked. Yes, because gradient positive. Remember, our dy dx is positive, so our v should be positive. Great. Oh, I give you a big clap. Clever boy and girl. I'm very happy. Okay. So now let's go into this. A particle move along. Okay, now let's look into example 7. Example 7, just now you never pay attention. Please pay attention now, at least when this question appear in your paper. It's either paper 1 or paper 2. For the first 2 parts, you hit a few marks. Please pay attention. A particle move along a straight line. Okay, I need someone to take over. Who wants to be volunteer to read the question and explain? While I listen, I need to take a rest after talking for more than 1 hour. Who can help me? Any volunteer? I pity your teacher talking 1 hour non-stop, you know. Hey, come on. Oh, John, you say you love teacher, right? John, are you there? John? Calling for John. See, John hilang already, sleep already. Can I have someone to read the question? Arnie, please, can you? Arnie?
Yes.
Read the question.
A particle moves along a straight line so that its displacement S meter after passing through a fixed point O is given by S equals to T cubed minus 9T squared plus 24T plus 5, where T is the time in seconds after movement started. Calculate A, the initial velocity in meter per second of the particle.
Okay, let's answer part A first. So what is the keyword of this question? Initial velocity, right? So here is the velocity. How do you get velocity from the S here? Can anyone answer to the question? Since Ami, you're reading, then you answer to this question. Later, I choose another one to answer B. How do you get V from S?
ds dt.
Okay, ds dt, you go to ds dt, then after that, you will get it as 3t squared minus 18t plus 24, right? You get this one? So after you differentiate, then when it says initial velocity, what do you need to understand?
T equals to 0.
Very good. Your t equals to 0. T equals to 0. See, you read this one, you have to do two works. Okay, you have to do two works in order for you to get the answer. So when t is equals to 0, your answer initial velocity will be of 24, meter per second. Okay, nah? Is that simple? So for this question, you will get 2 marks. Where are the 2 marks? The first mark goes to differentiating. The second mark is that you sub the value into the equation until you get the answer. You need to show you sub. Okay, the working is important. Okay, maybe there is no marks giving to you as subbing, but you need to show this working. This is a must show work. Okay, must show work, must show. Okay, thank you, Arni. We go to another student here. But I should ask to spin this one. Okay, let me. I never hear the voice before. Okay, Nabil, are you there? Nabil, hilang sudah. Nabil, hello. Tidur already lo. Never answer. Okay, Jai, are you there, Jai? Jai?
Yes.
Okay, you read B. You answer to B.
The instantaneous velocity in ms -1 at 3 seconds. So you sub t equals 3 into the velocity equation.
Okay, into the velocity equation. Okay, just now you have your dv dt, right? I should erase it, that one. ds dt, which is 3t squared minus 18t plus 24. So now you sub your t equals to 3 into 8. So the subbing is 1 mark and the answer is 1 mark. Give your value as well. Okay, you use your value. Give your limit unit as well. Okay, unit as well. So instantaneous velocity means that at that particular moment, okay, halaju seketika. Maksudnya halaju pada masa itu. Pada masa bila? Pada masa T sama dengan 3 saat. And how do you read this one? ms to the power of -1. How do you read this one? Jai, how do you read this one?
ms power of -1.
It's meter per second.
Oh.
Okay, this is meter, this is meter, this is meter, and this is second, but it's per second. Means that when we write, it should be in meter per second. Okay, that's why we read it as meter per second. Will that be okay? Okay, good. At least you learn how to read this unit. Good, very good. The explanation is clear. How about the rest? Okay, Anat? Yes or no? He's in toilet. Ayo. Oh. Okay, so now it says the instantaneous velocity of this particular at 3 seconds is this, okay? Is this unit. And C, the value of t in second when the particle is instantaneously at rest. What do you mean? Okay, Salome, can you please explain this one? C.
The value of t in seconds when the particle is instant. That means the velocity equals to 0.
Okay, very good. When the velocity is equals to 0. You need to understand this one when the velocity is equals to 0. So what do you do? What do you do? You have the equation of this one, right? You have the equation of this one. So V equals to 3t squared minus 18t plus 24. So when your V equals to 0 means that is your, this equation will be equals to 0. I want to have my fast work, so I padam the first line. So then what do we do? Salome, what do you do now after this?
Simplify.
Okay, how do you simplify?
Divide by 3. So
Okay.
it become t squared minus 6t plus 8.
60, 90 pula. Okay, luckily you are there for me. See, I short sendiri 60 plus berapa? 8, right?
Yeah,
Equals to 0. So then what do you do?
factorize.
Yes, you factorize. What's the answer?
T minus 2, t minus 4.
Okay, so you'll be having as t equals to 2 or t equals to 4. Okay, what do you understand this?
That means the particle U-turn 2 times.
Yes, you turn 2 times. Maybe we didn't really draw the graph, so we cannot see. What you can see that this particle is moving to the left. Say you assume that it moved to the right, okay, and then it make a U-turn to the left, and from the left it moved back to the right. This is what you can see. Move have 2 times of turning, right? Why do you say so? Remember what did you do just now? Just now we were talking about when V equals to 0. So what is V equals to 0 indicating us, telling us? This one, it says that turning, all this, when we say that it's making a U-turn, So we have 2 times where it makes turn. Okay, making two times turning. Where is the time that it makes turning? T equals to 2 and T equals to 4. Right. Okay, now I got, it's Yuda's turn. Yuda, please help me to explain part 4. Yuda. Where is Yuda?
Teacher.
You talk slow a bit, Okay.
Okay. So for part D, calculate the range of time in seconds when the particle moves to the left. So as we know, when the particle is moving to the left, the velocity of the particle must be lesser than 0.
Okay, must be less than 0. Good.
So we take the function of the velocity and sub into the equation of V lesser than 0. Then we solve it.
Okay. It's supposed to be 6t plus 8 less than 0, because just now this one, right, my equation? Am I right?
Yes.
Okay, so then what I do, I factorize. Okay, please record the lesson for your friends as well. So I factorize, I follow Salome's answer here just now. So what do I do? How do I determine my answer? Can you guide me? Can you guide us?
Then you can draw a number line or graph.
Okay,
Graph of the
draw a
function of
number
t
line.
squared,
Okay.
quadratic graph.
A quadratic graph of U shape or N shape?
U.
Of U shape. So what is the intersecting point here?
2 and 4.
On the left? On the left?
2.
2 and 4. Okay,
Yeah.
so then?
So the function is lesser than 0, so it's the bottom region. The region
Okay,
below
very
the
good.
x-axis.
Yes, it will be here. So that means your answer should be, your T should be?
In between 2 and 4.
Very good, perfect. Okay, perfect. So if let's say for exam question, when you ask me, I'll say that this question with the A, B, C, D, just now A, how many marks that I gave you? A is of 2 marks. B is of 2 marks. So 2 marks, and then 3 marks. This is 1 mark. Okay, this is 1 mark, and here this is 1 mark, and this is 1 mark, and this is 1 mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It might be 9 marks. Okay, the most can be 9 marks. It can be less than 9 marks. It depends because you are using the same function. So this one might not be given to you. Okay, so it might be 8 marks. If this is not given to you, they will consider this whole thing as 1 mark. It depends. It might be 8 marks. It might be 9 marks. This is through my experience of how I grade the question for marking. Okay, Annette? Do you understand this one? Yes or no? Yes. So remember, if you see this question, you must try. You must try to hit. Okay, so then I wonder this is example 7, right? Example 7, did you realize something is missing? Did you realize that something is missing here? Yes or no? Refer to your textbook. I can see example 7. This is example 7. And then this one is example 10. Yes, where is example 8 and 9? I also don't know. When I check the pages, no problem. It's 263 and this is 264. So editing problem. Okay, so Yuda, can you please help me? Seems that you explain quite, because you are guys lah. Salome is a girl. So I would like you to help me to explain example 10. Can you please? Yes or no? Yuda, where are you? Gone liao. What do you mean by gone? Okay.
Okay, so for example 10, a particle starts from a fixed point O and moves along a straight line. After t seconds, its displacement s meter is given by s equals to t to the power of 3 minus 3 t to the power of 2 minus 4t. Calculate the initial acceleration in m s to the power of negative 2 of the particle. So given the displacement function, s equals to t to the power of 3. Okay, so the function, and to find the acceleration, we need to find the second derivative of the displacement function. So we need to differentiate twice for the function of displacement.
dVds. Oh, wait, hold on first. 3t squared minus 9t minus 4. So dsc, I wrote wrongly. This is ds dt, this is dv dt, where this is my a and this is my v. Hold on. So 6t minus 9. Is this what you meant?
Yeah.
Yes. Okay, then what do I do?
That should be 60 minus 6.
60 minus, oh, sorry. Again, how can I overlook this one, the answer? I'll overlook, okay, this will be 6t and 6. Okay, good. Then,
So
what should I do?
They mentioned about the initial acceleration. So what can we understand from here is that the initial means t equals to 0. So we need to sub the t equals to 0, the value, into the function of acceleration.
Okay, then I get my a equals to negative 6. What is this one meant?
The initial acceleration of the object is negative 6.
Okay, the initial means that it slowed down, it's slowing down. What is slow down? Initial slowing down before it speed up. Okay, I can't imagine of a real life situation that something is moving in this. Can you give me some real life situation in this motion? Initial acceleration is slowing down. It is slowing down. Then it speed up again. Slow down. Or maybe it's a racing the bicycle cycling as you go up the hill. I can imagine that going up the hill that you can see that acceleration. Okay, is a deceleration because going uphill, right? So the speed also going down a bit, right? So until it reach the peak, it will zoom down. Okay, this is what I see in real life. Okay, very good. So this is what you say in A. Okay, how about B?
Okay, so for part B, it's actually the same. The question asks us to calculate the instantaneous acceleration of the particle in ms to the power of -2 at 5 seconds. So from here we know that the t is equals to 5, and we sub the t equals to 5, the value, into the function of acceleration.
Okay,
It's
this
actually
is
the
very
same as
simple. Okay, so you will get it as 6 times 5 is 30, 30 minus 6 is 24 meter per second per second. Okay, meter per second per second. Okay, good. Then after that, we continue to part C.
Okay, so for part C, calculate the acceleration of the particle in ms to the power of -2 when it passes through point O again. So
Okay.
from here, in order for us to get the value of acceleration, first we need the value of t, as the function of A is given by
Oh, slow down,
60
slow down,
plus-
slow down. Slow down. I need to jot down the
Okay.
point. So first, in order to, just now repeat your answer, in order for us to get,
the value of acceleration at the when it passes through point O again, we need the value of t.
okay, we need the value of t. Hold on, I need to jot down. We need the value of t. We need the value of t. What is the value of t? We need the value of t, okay?
So
Then,
then we need to think back from this statement, the acceleration of particle when it passes through point O again. From here, actually, we can get the information of t, where we can get some additional information. Okay, so as what our previous knowledge tells us, that when it passes through point O again,
and when
its
it passes
displacement
through O
through the
again,
point O again, the displacement of the particle is actually equals
Pardon?
to 0. The displacement of the particle is actually equals to 0.
yes. So here you,
Hello, teacher.
meaning that your S is equals to 0. Am I right?
Yeah. That's the additional info for us to get the value of t.
Okay, so your S is equals to 0 because of this, that you know your answer. Why my screen never move already? Wait, what happened to my line? Okay, my line has gone don't know where already. Okay, now what happened now is I go back equation of S. S will be equals to t cubed minus 3 t squared minus 4t. So then this is equals to 0. I factorize my t squared minus t3 minus 4. Am I right? Are you using this?
Yes, yes.
Yes, okay. So t, then I'll get 0. Then I factorize this. It will be t. And what's the answer here? Is it 4 and 1?
Yeah. Positive 1
Okay,
and negative
so what
1.
happened?
Yeah. So
Oh,
from
1
this,
and negative. Okay, from here, what do you get your t? Your t
t
is,
equals to 0, 0.
okay,
T equals
or,
to negative 1,
okay, good, or
t equals to 4.
t equals to 4. So you have two answers. Remember our time, we take the positive. Time, we cannot take the negative, right? Okay, now, then continue.
Okay, so for t
So
equals to
as
0,
now you can see,
that's the initial one. That's the initial where we start our movement. So we need to take the t equals to 4. We ignore the t equals to 0 because that's the
Okay.
initial time.
okay. So,
So
but now what you want? You want the,
value of a.
again, right? Again means that not this one, not this one. This is the starting. So we don't take this one. We take this one. We take when the t equals to 4. Okay, now we continue. Where am I going to sub?
Sub into the function of
Where am
a.
I going
A
to?
equals to 6t minus 6.
Okay, why do you sub into this function instead of the other?
Because they want us to calculate the acceleration, right?
Yes, you go back to the question, and the question is asking us for the acceleration. So we sub into the acceleration of it. So 6, 4, 24, 24 minus 6. What do you get? Where do I get? I get 18, right? 18
yeah.
meter per second per second. Am I right? Okay. So the floor, kawan-kawan yang lain, do you have problem? Do you understand this one? Part C? Is it part C? Right, part C, right? Yes or no? Faham tak? So Yuda has explained very clear as he reads the question and then he guides us what to look for first. Okay, in order to look for the time you pass through 0 again, or the starting point again, remember, this is what we need to look for, s equals to 0. So you need your equation. So sub your s equals to 0. When there, you get your time. Bila dah dapat time, don't forget you tengah cari acceleration, sub the t into the acceleration equation. Right. Okay, now the last one, who wants to try? Siapa nak cuba? Later I call Salome again. Then you say, teacher, why you always call her? How about the rest? Shamin, you are here, Shamin? Shamin? Shamin, are you there? Hilang already ah? My mic spoiled. Hey, go and get the mic. Okay, siapa punya mic? Who wants to try? Who wants to try? Yixing. Come on. Otherwise, you leave my room later. Come on. Yixing, you take over lah. Why like a girl like that? Yo. Ask you to take. See, look
okay.
at
Okay,
Don't be like
okay.
a girl.
So the range of
Wait,
values of
wait.
okay, can.
I am the one who slowed down. Okay, now go back to my question. Okay, I need to project you the question. Okay, I clean up this one first. Okay, now you read.
The range of values of t in seconds when the acceleration of the particle is positive. So they say the acceleration of the particle is positive, so a is greater than 0.
Okay, good. This is your point. A is greater than 0. So what should I do?
So you take the velocity punya equation and then
Okay, you take
greater than 0.
You take the velocity punya equation. Also, I take the velocity punya equation. Velocity punya equation.
The one
The
that's been,
acceleration.
acceleration.
I take
Sorry.
which equation that I take? I take the velocity or take the acceleration?
Acceleration.
Okay, because of a is greater than 0, so I take this equation where it is 6t minus t greater than 0. So what is the next step?
Then just solve it. Bring the
How to solve?
negative 6. The negative 6.
Then?
For me, I will just put the negative 6 to the other side.
Oh, okay. I'll put the negative 6. So you do it this way.
Yeah. And then divided
okay.
it by 6, and then t will be greater than 1.
Yes, done. Is it simple? Is it simple or not?
Yeah,
Simple.
simple.
Okay, now before you say simple, let me capture this picture first. I got question to ask. Because always when I'm guiding you, I got question in my mind. That's why my PDP also gone flying out from my script. I don't have script, when I teach. Okay, now back to this one. Now, I have a question to ask. Everyone think of it. Can this one be equals to, can I have my t equals to 1? Can I have the sign of equal here? Yes or no? Think of it. Why can't I have why your answer never have t greater or equal? You just tell me your answer is t is greater than 1. But why you never tell me that your t is greater or equal to 1? Why not this one? You accept this one, but not this one. This is with the sign of equal. You don't accept. Why? Can anyone answer to this question? Hot question comes in. Make you think. Why? Go back to your earlier information. Because the acceleration value will be 0. Okay, Dan? Okay, very good. Danisha, your explanation is good. Then why? If it is 0, then why? Why can't? Okay, very good, Danisha. You get the t, you make that t equals to 1. You make t equals to 1, you sub into here 6 times 1 minus 6. You get a equals to 0. Very good, but you did not explain. Okay, you work it out, but you did not explain. Okay, come on, put your mind together and help Danisha. Why? Go back to your very basic knowledge of 0. The first time when you were introduced about numbers. Can anyone give me the answer? If as let's say the particle won't move. Yes, because 0 is not a positive. 0 is a neutral number. Okay, go back to your very basic. Don't forget, bila kita dah belajar tinggi-tinggi, jangan lupa landasan kita. This is 0. This is what we call integer. Positive integer. This is positive integer. And this is negative. Okay, this is negative. This is negative integer. Integer negative. Right? And how about 0? How about 0? 0 is neutral. N-E-A-U-T, N-E-A-N-E-A-U, neutral. Okay, how to spell neutral? Okay, it's neutral. Okay, 0 is neutral. Okay, N-E-U, why I got A? Thank you, Yising. And how to spell? N-E-U-T-R-A, neutral. Okay, 0 is neutral. So 0 neither positive, neither negative. That's why we cannot have equal. Because if it is equal, you will make A equal to 0, where 0 is neutral. It doesn't show. That's why we cannot include the 1. Okay, Anna? So remember for this, because when you give the time of range, when do you include 1 and when do you can't include, when you can't include 1? You have to go back to the question asked, right? So then maybe after this, be ready, okay? I need one more slot to go to example 11, example 12, example 12, example 12. Example 12 only, we have. Example 12 and example 13. I have 3 more examples that I'll do on Monday. Then I'm going to close this topic. Okay, I need 3 more examples. So everyone get ready to stand by to present your explanation. The answer is there, the working is there. I need you to tell me the story only. Retell the story to give you some confidence in doing the work. And later I'll post you 1 question and 1 will be selected to explain. Right? So I shall stop my recording first. Later.